we can use the Huffman algorithm to find an optimal coding tree for compressing a given message. So here I have this message, AAAAA, BBAHH, BCB, GCCC, and here is the algorithm for constructing the Huffman coding tree. First, I compute the frequencies of the symbols in my message. Then I start with a forest of single node trees that contain the symbols with their frequencies. So I'll do that first. So my symbols, the first one is A. So I'll maybe do this over here. So A has a frequency 6. Then the next symbol I'll look at is B, which has, and I'm just counting the number of occurrences. A, 1, 2, 3, 4, 5, 6. B has a frequency of 1, 2, 3, 4. C has a frequency of 1, 2, 3, 4. D has, oh, sorry, there's no D. The next letter is G, which has a frequency of 1. And then the last symbol is H, which has a frequency of 2. So these are my symbols, my unique symbols with their frequencies, and I've created them as a forest of single node trees. So my forest will always be represented by roots of trees. So each of these is the root of its own tree. So while there is more than one tree in the forest, first I remove two trees, T1 and T2, that have the lowest frequency from my forest. So the lowest frequency, G1 and H2, 1 and 2 are the lowest frequency. So these two are so I'll call this T1, this one T2. Then I create a new node whose frequency is the sum of their frequencies to be their parent. So I'm going to make a new node whose frequency is the sum of their frequencies, and it's going to be their parent. And I'm going to label the edges 0 and 1. Then I reinsert that node into the forest. So now my forest is A6, B4, C4, and this new node that I've created. And one thing to emphasize is that when I'm creating left and right 0 and 1 children, it's important to be consistent. So for example, here I'm going to be making, I made G1 be the 0 child. In your implementation, you have to make sure that you're consistent such that anytime you run this, it'll always give you the same result. Okay, so next iteration, there's still more than one tree. So I remove the two trees with the lowest frequency. So I have 6, 4, 4, and 3. My two lowest frequencies are 3 and 4. I have to break ties somehow. I'm just going to, in this example, arbitrarily pick C4 to be the next one. In your implementation, you have to break ties consistently. So now I'm going to create, so T1, T2. I'm going to create a new node whose frequency is their sum. So 3 plus 4 is 7. These become the children of that new node. And I insert it into the forest. So now my forest is A6, B4, and 7. Next iteration, there's still more than one tree. There's 3 trees. Remove the 2 trees with the lowest frequency. So my frequencies are 6, 4, and 7. 6 and 4 are the lowest. I'm going to create a new node whose frequency is their sum. So 6 plus 4 is 10. 0, 1. And now I'm going to insert this node into the forest. So now my forest is these two nodes, 10 and 7. There's still more than one. There's 2. So I remove them. I remove 2 trees. There's only 2 trees left, so I remove them. Create a new node whose frequency is the sum of their frequencies. There we go. Make them its children. And reinsert it back into the forest. While there is more than one tree in the forest, nope, there's only one node, there's only one tree in the forest, the tree rooted at 17, so I'm done. Now this is my Huffman tree.